Where do we go when we sleep? Are dreams simply our own imagination or something else? Are you harboring a black hole inside you? All of this and more explored tonight on PBS Post Biggles Scriptum. Stay tuned for more. The future states there is no time other than the collapsation of the sensation of the mirror of the memories in which we are living. Science 101. Before I bend your minds into irrecognizable blobs of their former standing, we need to cover some basics to get on the same page, so to speak. Are we sitting comfortably? Good. Let us proceed. Wave-particle duality. Dual-slit experiment. The double-slit experiment demonstrates the principle of wave-particle duality, showing that matter and energy, such as light and electrons, can exhibit the properties of both classical waves and classical particles. It also illustrates the concept of quantum superposition and the effect of measurement on a quantum system. In the experiment, a stream of particles is directed toward a barrier with two thin, parallel slits. On the other side, a screen registers where the particles land. Wave-like behavior. When particles pass through the slits, they produce a striped interference pattern on the screen, a phenomenon characteristic of waves. The wave from one slit interferes constructively and destructively with the wave from the other slit, creating bright and dark bands. Particle-like behavior. The particle nature is shown by the individual impacts recorded on the screen, which build up over time to form the interference pattern. The paradox. This behavior persists even when particles are fired one at a time. The lone particle still behaves as a wave, passing through both slits simultaneously and interfering with itself. Superposition and measurement. The experiment reveals that a quantum entity exists in a superposition of all possible states until it is observed or measured. The act of measurement itself profoundly affects the system. Unobserved. When no detector is placed at the slits, the particle's wave function travels through both slits, and the wave interferes with itself, creating the striped pattern. Observed. If a detector is placed near the slits to determine which one the particle passes through, the interference pattern disappears. Instead, the particles behave like classical particles and produce a pattern of two distinct bands. The measurement forces the particle's wave function to collapse into a single, definite state. Schrödinger's cat. This hypothetical scenario, and I must stress a hypothetical scenario, animal lovers, places a cat in a sealed box with a device that could potentially kill it. According to the standard interpretation of quantum mechanics, until the box is opened, the cat is in a quantum superposition of states, both dead and alive simultaneously. The act of opening the box and observing the contents forces the superposition to collapse into a single, definite outcome. Either the cat is alive or it is dead. Dimensions. We live in a four-dimensional universe that includes three dimensions of space, length, width, and height, and one dimension of time. We perceive and can move through the three spatial dimensions, but we move through time only in a forward direction, a concept that Einstein's theory of relativity showed are intertwined. Advanced theories, like string theory, suggest that more dimensions may exist, but they are beyond our everyday experience and direct observation. Our brains are wired to perceive the three spatial dimensions we live in: length, width, and height. We can easily visualize a lower dimension by removing one of these dimensions, such as imagining a 2D plane, like a drawing on paper. But can you imagine a 1D line? To imagine a new, orthogonal dimension that is perpendicular to all four of our existing ones is practically impossible for most people. The many worlds theory. The many worlds theory is an interpretation of quantum mechanics that proposes that all possible outcomes of a quantum event are physically realized in different, non-interacting parallel universes. Instead of the wave function collapsing to a single outcome when observed, it suggests that the universe branches, with every possible result happening in its own separate universe. Many Worlds proposes that the universal wave function is an objectively real entity that evolves deterministically according to the Schrödinger equation. It eliminates the measurement problem, the core paradox in quantum mechanics that explains how a quantum system in a superposition of states resolves into a single, observed outcome. Instead of a collapse, the universe splits. The appearance of a single, defined reality is explained by quantum decoherence. When an observer interacts with a quantum system, their wave function and the systems become entangled. This interaction causes the different outcomes to become effectively branches or worlds. Since all outcomes occur, probability is not a measure of potential outcomes but is reinterpreted. The probability of an outcome is related to the measure or weight of the branch in which it occurs, leading to an illusion of randomness. Black holes, expanding upon the revolutionary research undertaken by Dr. Dan Thorpe. I find myself on a most interesting crest of scientific discovery, that of black holes residing within ourselves as well as within the great expanse of the universe. Black holes are most famously difficult to observe due to their very nature. Photons which venture too near a black hole are unable to escape its gravitational pull, leaving no direct means of observation to the human eye. Newton's third law, which is a fundamental principle of physics, states that for every action, there is an equal and opposite reaction. These paired forces, known as action-reaction pairs, act on two different interacting objects. Photons, too, enter the human eye but do not escape, much like a black hole. Ergo, when considering the duality of the universe, humans observe, black holes obscure. It is therefore painfully plain to see Newton's third law in action right in front of, or perhaps within, our own eyes. If not a black hole themselves, our eyes are a sort of anti-black hole, that is not to say against but rather of the same kind situated opposite. Black holes are often described as a singularity, that is, a point where a system breaks down or becomes undefined. What lies beyond the event horizon? My theory is that black holes are gateways to extra dimensions. It is widely accepted that there is a black hole at the center of the universe. Therefore, is it not unreasonable to believe that the Big Bang may in fact just be the arse end of a black hole from an extra dimension above which we cannot envision? Conclusion. So, where do we go when we sleep? Simultaneously nowhere and everywhere, like Schrödinger's cat. The act of opening the box and observing the contents forces the superposition to collapse into a single, definite outcome. Either the cat is alive or it is dead. So accounting for all that is true so far, I am here to postulate that when we dream, it is not our subconscious which independently conjures up such images and thoughts from nowhere. Common knowledge is that as you begin to fall asleep, alpha waves are replaced by slower theta waves, which are replaced in deep sleep, often referred to as slow wave sleep, with delta waves, very slow, high-amplitude waves. It is these high-amplitude waves which are interconnected by the process of quantum entanglement to the probability wave. That is to say that our brains are, in their slow wave state, observing the quantum fluctuations of possible probabilities, which when observed become truth. Time is merely the observance of the measure or rate of change. That's why time does not feel like it applies when we sleep, as we are not an actively participating observer when we sleep. Imagining a universe one dimension below our own leaves us in a three-dimensional world, where we have length, height, and width but no time. It is this lack of time which allows for any combination of imaginable curiosities which we deem dreams. As such, if we, the observers, were to collectively dream whereby the same probability wave is observed by all, the superposition would collapse into a single, definite outcome which becomes reality. Nothing is impossible, the odds are simply highly improbable.
And just remember, everything you are is more important to realize the negative space, as music is only the division of space. It is the space we are listening to, divided as such, which gives us the information in comparison to something other that gives us the idea of what the idea that wants to be transmitted wants to be.